Let's look at final exam question number 22 in Electronics Demystified 2nd edition. If you have the printed edition, you'll find it on page 421. In this question, we're being asked, in an AC circuit, what do conductance and susceptance combine mathematically to give us? Well, this is a situation very similar to the situation in the previous three questions, except similar but dissimilar in the sense that it's flipped inside out. Figure exam-3 once again showed resistance on a horizontal axis and reactance on a vertical axis, and I recommend at this point that you watch the videos for questions 19, 20, and 21. They'll give you a really good idea of what goes on in complex impedance, which is the combination of resistance on the horizontal axis and reactance on the vertical axis. Well, here I've taken figure exam-3 and scrawled in a couple of changes that may look kind of minor on the surface of it, but mathematically they couldn't be more major. Resistance has been replaced by conductance, which we symbolize as G, and reactance has been replaced by susceptance, which we represent as B or JB. Conductance is the reciprocal of resistance, where resistance represents the opposition to current. Conductance represents the extent to which a circuit allows current to flow. So it's conductance is the reciprocal mathematically of resistance. Susceptance is the same deal with respect to reactance as conductance is with respect to resistance. Susceptance is the ease with which a reactive component like an inductor or capacitor will allow AC to flow. There's one important difference here. Susceptance, positive values represent capacitance and negative values represent inductance. And this point in the complex impedance plane, where we have R plus JX, this point would represent a dead short circuit, but in the complex admittance plane, which is what this is, this point represents an open circuit. So, conductance and susceptance combine mathematically to give us complex admittance. Admittance is the ease with which a resistive and reactive circuit, or if you prefer conductive and susceptive circuit, combine to allow AC to flow. So the correct choice for question number 22 is D, admittance.